All right, so proving the units. You want to prove that meters are equal to kilogram meters per second over Coulomb Teslas. Remember what we said about proving the units? Substitute one in at a time and show me. So we know a Tesla from F equals BIL sine theta. We know that B is equal to F over IL, which means a Tesla is equal to a Newton over an amp meter. So where a Tesla is kilogram meters per second, we can put a Newton over an amp meter. Now, dividing by a fraction is the same as multiplying. So kilogram meters per second. And really, this is the same as the Coulomb could be on top. So I could multiply by an amp meter over a Coulomb Newton. Okay? The next thing I might want to do is say I is equal to Q over delta T. So an amp is equal to a Coulomb over a second. So a Coulomb is equal to an amp times a second. So if I put that in here, kilogram meter per second times an amp meter over an amp second. The amp's going to cancel. And so I'll have M is equal to kilogram meters per meter squared per second squared. I lost a Newton. Sorry, Newton. And a Newton. But what's a Newton? Well, a Newton is from F equals MA. A Newton is a kilogram meter per second squared. So where this is, mass is equal to a kilogram meter squared over a second squared, and this is 1 over, I just moved it out, kilogram meters per second squared. Dividing by a fraction is the same as multiplying by the reciprocal. So, whoops, there's really a G there. Kilogram meter squared per second squared times a second squared over a kilogram meter. Second squared cancels, kilogram cancels, 1 meter cancels. Units are solved. Meter equals a meter. Okay? I'd now like you to go over in your textbook to page 553 and do numbers 4, 7, and 8. They are with this equation. Okay? When you finish them, then I want you to go to the sheet that you did 1 and 2 on and do numbers 4 to 9. So 4, 5, 6 on page 553, and then 4 to 9 on the sheet. Okay? And that is it. We will do the force between two current carrying wires the next day I see you. Okay?